Welcome to video number 431. In this video, I'm going to estimate technical efficiency using stata. So I would like to start with the definition of technical efficiency, and technical efficiency is the effectiveness with which a given set of inputs is used to produce an output. And a firm is said to be technically efficient if it is producing the maximum possible output from the minimum quantity of inputs, including labor, capital, and technology. Technical efficiency requires no unemployment of resources. That is, all the resources, including labor, capital, and technology, are fully employed, and there is no underemployment or unemployment of any of these resources. We may also explain the concept or the idea of technical efficiency with the help of this production possibility curve. This curve, which is concave to the origin, is known as production possibility curve or production possibility frontier, or it is also known as production possibility boundary. Any point on this production possibility curve will be technically efficient, and any point below this production possibility frontier will be technically inefficient. But any point above the production possibility frontier would be impossible, because we cannot produce more than any point on the production possibility frontier. Let us suppose that the economy is producing two goods, guns and butters, and it can produce, using all inputs including labor, capital, and technology, it can produce the maximum of butter from 0 to this point, or the maximum of guns and no butter with all the available resources from 0 to this point, or it can produce any combination of butter and guns showed by points like A, B, and C. So it means if the economy is producing on the production possibility frontier, then it is known that this economy is technically efficient. If it is producing below the production possibility frontier, like at point C, then this point is technically inefficient. Given a certain quantity of inputs, technical efficiency will be achieved when the economy is producing the maximum output possible. We could produce all guns or all butter, or any mix of guns and butters as shown by point A, B, and C. We may also define technical efficiency rate as the ratio of actual output from given inputs divided by maximum potential output from given inputs multiplied by 100. Let us suppose we take an example of a firm which is producing 300 cars per week from its all resources. And if you know that the maximum possible output of this firm would be 320 cars per week, then the technical efficiency rate for this firm would be 300 divided by 20 multiplied by 100, and that would be equal to 93.75%. So it means that this firm is not technically efficient. It is producing less than its potential output, and there is some degree of inefficiency. In this case, some inputs including workers or labor or technology would be underemployed or unemployed, and there is a degree of some potential output missed. In order to estimate the technical efficiency, we will use some example data set using stata, and for that purpose I would like to open my stata file. I have already opened my stata data here, and let me show you the data before I analyze technical efficiency. This is State-wise data, this is cross-sectional data, and total number of states used in this data set is 25. This is the total production or the total output, and this is the amount of capital used, and this is the amount of labor. These are the number of firms from different states. 68 firms are from Alabama, 1372 firms are from California, and so on. Finally, we have 142 firms from Wisconsin. Data in this column is natural log of total output, this is natural log of capital, and this is natural log of labor. So after showing you this data, I will analyze the data as follows. As I mentioned, my data is here. So first of all, I would like to estimate the Cobb-Douglas production function by giving this command regress natural log of output, which is regressed on natural log of capital and natural log of labor. So here is my estimated Cobb-Douglas production function. This is the analysis of variance. These are the total number of observations for 25 states of the United States of America. This is the F state, this is its p value, this is r squared, and this r squared shows that 97% of the variation in total output is explained by variation in capital and labor. This is adjusted r squared, and this is a root mean square error. This coefficient shows the elasticity of output with respect to capital, and this is elasticity of output with respect to labor, and this is the constant of this model. These are constant of this model. These are the standard errors, these are the t values, and these are the p values, and these are the 95% confidence interval. I will be comparing this estimation with the estimation of frontier production function. So I have this command frontier natural log of v, which is a dependent variable, followed by two independent variables, which is a natural log of capital and natural log of labor, and this gives me estimation of the frontier production function. These are the number of iterations, this is the log likelihood, these are the number of observations, this is Wald chi-square test, and this is its p value. This is the elasticity of output with respect to capital, and this is elasticity of output with respect to labor, and this is constant of the model. Now both the coefficients in the Cobb-Douglas production function and in the frontier production function model are almost the same. There is a little bit difference between the numerical values of these estimates. But these two variables in both the models are statistically significant. There are some other statistics, and here we have the LR test for sigma u, and its p value is 0.256, and this shows that we failed to reject the null hypothesis of this test. Now, after estimating the frontier production function, I will predict the residual of this regression, and here this shows that this variable has been created. And after this, I would like to sort this variable of the residual by this command. Now it has been sorted, and finally now I will give this command predict efficiency comma te. Now it will estimate technical efficiency, and you see it has been generated or created here. So I can share this with you in this. Previously I had data up to this point, then I generated this function, which is the residual of this model, and this is the efficiency level of this model. Now this variable shows, this value shows that there are 31 firms from Kentucky, and these firms have technical efficiency rate of about 95%. There are 247 firms from New Jersey, and there the technical efficiency rate is 91%. And similarly for firms from Kansas, the technical efficiency rate is above 90%. So up to Georgia, that is Kentucky, New Jersey, Kansas, Missouri, and Georgia. So firms in these 5 states have technical efficiency rate of more than 90%. Then after that, we can see that firms in Washington, Illinois, Maryland, Virginia, up to Ohio, These firms have efficiency rate of more than 80% but less than 90%. And finally, three states, that is Iowa, New York, and Florida, have firms whose technical efficiency rate is above 60% but less than 80%. So this is the estimation of technical efficiency. But let me tabulate this, so I can use this command,egen command, for this frequency of efficiency group, and I am using this cut efficiency data at 0, 0.6, 0.8, 0.9, and 1. So if I click this, it has now generated a new variable. But before that, let me show how to tabulate this newly generated variable, and it will give me the frequency of the various technical efficiency rate in a table of form. And here is the table, and this table shows that firms from five states have technical efficiency rate of more than 90%. Firms from 17 states have technical efficiency rate from above 80% but less than 90%. And three firms from three states have technical efficiency rate of above 60% but less than 80%. So ladies and gentlemen, this is how we can estimate technical efficiency. So I generated this one variable, which is a residual. This is the efficiency, and this is the group. And I showed also the table, this frequency table of the technical efficiency rate of firms in various states. So overall, 20% of the states have firms which have technical efficiency rate of above 90%. 68% of the states have technical efficiency rates of above 80% but less than 90%, and 12% of the states have firms whose technical efficiency rate is greater than 60% but less than 80%. My dear students, ladies and gentlemen, this is how we can estimate technical efficiency and how we can interpret. If you like the video, you may subscribe to the channel, and please do not forget to click on the bell icon so that you can get timely notification about my other videos that I'll upload for you. I thank you very much for watching this video and channel. I would like you to share various videos of this channel in various WhatsApp groups so that these could reach to the maximum possible number of people.